Okay.
Okay, we pretty much got this, okay?
Okay.
Except by overthinking a little bit and not believing the obvious thing. And of course, you have to know how to check that out. And that's part of learning the process of problem solving. Okay, so it's pretty obviously the rate times the time interval, because the rate tells you how much per unit of time, and you multiply that by the time interval. And you know, people had that written down, okay? So that's, I regard as pretty obvious, and this one really obvious because the rate flowing out is the same as the rate flowing in, so the amount of pure solvent that flows in is equal to the amount of mixed solution that flows out. Then how much solute flows out? Well, be 50% of R delta T. Okay? Make sense?
Mm-hmm.
Now that's not exact, but in a microsecond, the concentration in here isn't going to change enough to worry about, right?
All right.
Okay? And since we're going to be taking a limit as delta T approaches 0, we don't worry about that little bit of difference. However, we go on to another question, okay? So the question is this now. When the amount of solute is Q of T, because the amount of solute in here is clearly changing with in time, right?
Right.
The amount of Dr. Pepper in this example.
Right.
But the amount of solute is Q of T, then the question is, how much solute flows out in a short time interval, delta T.